screen visible?
Yeah.
Yes, yeah.
Cool. Okay, so thanks everyone. Thanks for joining. Appreciate it. Sorry for a delay of 9 minutes. Sorry for that. Okay, so we had some technical challenges, so that was the reason. So welcome all once again. It's a long gap, so we are just another meetup. So this is our 11th meetup, right, Supriya? If I am not mistaken, right? Yeah, 11th.
Yes.
Yeah.
Yes.
So today we are on an exciting topic actually, and which is Anypoint Runtime Fabric, which is the need of the hour on self-managed Kubernetes on Google. We chose the platform as Google, so that's a topic for the day. And once again, apologies for the delay, and welcome all. So just the safe harbor statement. So the speakers and we, and whoever is organizing this meet, we are doing this in our individual capacity only, and we are not representing our companies here, right? So the presentation is strictly for learning purpose, and the organizer presenter do not hold any responsibility that same solution work for your business requirement. So we can always try it, but it's not recommended for a production environment. So and the presentation is not meant for any promotional activities too. Just on the housekeeping side, we will be having a recording of this meetup that will be uploaded later within 24 hours. And questions can be submitted or asked at any time. And I would say, let's keep all the questions to be towards the end of the presentation, which will give a speaker enough time to discuss all these rather than, disturbing the flow of the speaker, right? And but we have a general question answers tab is there. We can make use of that, and let's make it interactive later. And of course, guys, always give us feedback and rate this meetup session by filling feedback form at the end of the day. And we always love feedbacks, and and we also would like to have new speakers coming up and organizing it, and we approaching us for new topics. Always welcome. So yeah, organizers. Supriya, go ahead.
Yes. Hello, everybody. Thanks for joining today's meetup. My name is Supriya, and I'm as you see, a leader at Kochi Mulesoft Meetup group. 8+ years of experience I have completely into integration, certified into
Let
integration architect, platform
me
architect, and
let
developer.
me give my introduction first. Meanwhile, she comes.
Sumit, I was already talking. Hello,
Yeah. So myself, Sumit Ahuja. I'm one of
There
the
is some
leader at
delay.
Microsoft.
hello.
Sorry, Sandeep.
I think Supriya is already talking, Sumit.
Supriya is
Oh,
already.
okay.
Yeah, that's what Sumit. Maybe you can rejoin.
I think he was
I
not able to hear.
yeah,
It looks
maybe
Yeah,
like
he
yeah.
was
he's not
There
able
is
to hear.
there is a
not
lag.
able to. Yeah, maybe. So yeah, I was saying that architect and developer certified I am, and currently I'm into London. So joined as associate manager, come integration architect in Accenture. Thank you so much. Thanks again for joining all of us. I'm sure you're gonna enjoy this session. And Siddhama, thank you so much for coming ahead and nominating yourself as a speaker. I'm looking forward for a nicest session from you. Thanks.
Sumit, go ahead, man.
Yeah. Thank you. Am I audible? Can you please
Yes,
confirm
yes, you
once?
are. You are.
Yeah.
Yes.
Okay. Okay. So yeah, my Sumit Ahuja. I am also one of the leader at Kochi. I have total 6.5 years of experience in integrations and API technologies. I'm currently working as an integration architect at Wipro. Yeah. Thank you all for joining. I hope you will. I hope the session will be that helpful and informative. Yeah. Thanks for
Yeah,
joining.
thanks, Sumit. And everyone, my name is Sandeep Krishnan. So I'm also a meetup leader at Kochi. I work as a technical instructor from Mulesoft and also an integration lead. Experience-wise, I've also got 10 plus years of experience, certified developer, architect, platform architect, all these levels I've been working. So thanks all once again, and really, really appreciate. Thank you very much, Sidama, for taking time, taking the initiative, doing a lot of hard work. Last we know that we have done a lot of things. So I'll just hand over to you, Sid. You can just give your introduction, and then we can continue, I guess. So I'll stop sharing now. Okay.
All right. So I'll start sharing my screen,
Yeah, you can share.
Sandeep. Yeah. So let me know if you're able to see my screen.
Yes, yes, we can.
Okay, so I'll give a quick introduction of myself. So basically, I work as an integration architect with over 14 years of experience in IT. And in MuleSoft, with MuleSoft technology, I've been working for almost more than 5 years now. Currently, I'm working with Devo team here in Netherlands, Amsterdam. And my area of expertise is within enterprise application integration. I've worked on different stacks of integration products, mainly IBM Suite and MuleSoft. Um, I've been working on different large scale enterprise architectures, implementing their integration patterns and transformations, and we've worked very hard to meet their integration requirements. So that's the work that I've been doing so far. So that's all about me. Apart from that, I'm pretty much interested in exploring new technologies and understanding how those can be integrated and help the enterprises unlock data and achieve digital transformation. Yeah, so that's about me. So in today's topic, right? So the agenda for today's topic is that we are going to explore and understand runtime fabric on self-managed Kubernetes on GKE. So so basically, the topics that we'll be covering is first of all, we'll want to understand which are the different MuleSoft deployment strategies that are followed, and try to understand what is containerization, because the whole idea of having RTF and why we are talking about containerization and how RTF comes in picture and how it helps you to automate this entire containerization feature is important. So we'll touch upon what is containerization. Then we will talk about overall RTF architecture, how it works. There are two different flavors. You have one for VM bare metal, and the other one is self-managed Kubernetes. So how these two are different, we will touch upon that topic. Then we'll try to understand the RTF architecture for self-managed Kubernetes on GKE. And then the most important one, which you guys might be interested, is we'll do a hands-on session wherein we will actually set up the VPC, the Kubernetes cluster, apply the license key, and then deploy a simple Mule application and see how it works, right? So we will actually see that demo session. So anybody in the audience who's interested in doing this hands-on session along with me, it should not take you much time. You can probably just open the Google Cloud console and enroll for the trial version. It comes for with 90 days validity, and they give you some initial credit of around $300. If you're in India, it's somewhere around $300. So you can register and keep it ready, and the rest of the steps you can follow with me, and you can do the hands-on as well if you are interested. Otherwise, which you can just follow the video that will be uploaded later on and try it yourself. Yeah. Um, so let's get started. So first of all, you might already know, most of you will be working on different deployment models, strategies that we follow in any point, right? So you have Cloud Hub deployment strategy, wherein the control plane and the runtime plane, everything is there on your Cloud Hub Anypoint platform, and it is completely managed internally. It is again, hosted on AWS. So that's your Cloud Hub deployment strategy, where you do not have to do anything for provisioning the infrastructure, everything is taken care by Cloud Hub. So this is most of our customers going for Cloud Hub. So you will have worked on Cloud Hub, so you pretty much understand and correlate what we're addressing here. So basically, your control plane and your runtime plane, both of them are on cloud. uh, in some cases, customers go for something called as a hybrid model. Here what you see as a, just a second. Yeah, so here what you see here as a standalone Mule installation, we can also call it as a hybrid model. Hybrid as in the control plane, right? So when you say the control plane, you have your API manager, your runtime manager, and all of that on your control plane, from where you can view um, and control the way you're deploying the applications, the way you're applying policies. All of that happens in your control plane. But your actual runtime and the mule application that you deploy is on premise on the servers that you set up. So here, what happens is the customer has to create a VM, then install the mule servers and do a complete on premise setup here for the runtime. So basically, there is a shared responsibility wherein the complete runtime plane is managed by the customer, and the control plane is on the cloud, right? So this is the hybrid model that you will have seen. Apart from this, if you would have attended any of my one of the last meetup that I did, where I was talking about how you can do your containerization in the hybrid model as well, right? So this is a standalone approach wherein you just have standalone mule runtime servers, but you can also do containerization, as in you can create a Docker image file, and then spin up the mule containers, and within those containers you can host your or deploy your mule applications. Then you create a cluster. You can also have Kubernetes on top of that. You can do all of that, but that is more of a very cumbersome process, right? Because you need to do all of those steps. You have to spin up each of them, and the Kubernetes cluster, your Docker management, all of that has to be taken care by you, right? So you don't have a way of controlling it from your control plane. Now we come to the runtime fabric. How runtime fabric solves this problem is it gives you a level of abstraction where you can only focus on deploying your mule applications in the hybrid model itself. It is still a hybrid model because your control plane is in the cloud, and in the appliance model, right, what we have is your servers. They sit on your in your on-premise bare metal or VM, and it gives you the runtime fabric gives you an abstraction from where you can actually deploy your applications, control your applications from your control plane, your runtime manager, and your API manager, right? So that gives you that kind of a flexibility. Now, otherwise, which if you're not using a runtime fabric, you'll have to do all of this activity in a very manual way, and the way you would control and manage these applications which are running on a containerized nodes or servers would be much more complex, right? And it involves a lot of operations and other activities. So runtime fabric helps you there. Now, in runtime fabric itself, we have two approaches of how we can leverage, or we can model and leverage utilize this runtime fabric. One is your the VM or bare metal, wherein you will install your runtime on your VM, and the other one is your self-managed Kubernetes, wherein you will utilize the services provided by the cloud offerings like AWS, Azure, or Google, right? So if I go to that, so yeah, basically let's finish off with this topic. So basically, these are the two flavors that are provided with runtime fabric, right? So we'll touch upon that as we move ahead. All that you need to understand is we are trying to containerize our mule applications um, on the on-premise setup here, and they're trying to utilize Kubernetes and Docker. Now, you might say, on Cloud Hub itself, we already have the same concept, right? You have workers. So you are containerizing, you have application isolation. Then why go for runtime fabric when we can do it in Cloud Hub? If you think it in that direction, the flexibility that runtime fabric gives you is you can still have containerization. You can have the flexibility of controlling how you deploy and manage your applications from control plane. You can have so these two benefits you get. The additional flexibility that it gives to our customers is the customers who are using, say, Azure. They don't want to have their applications running on Cloud Hub. They want to run their applications within their own flavor of cloud. They want to use Azure, or they want to use their own uh, virtual private cloud of AWS itself, or they want to use Google Cloud. So for these customers, that's where this runtime fabric comes into picture.
Hey,
So
Sidham,
that
sorry to interrupt you in between. Just wanted to confirm with Sandeep. Is the recording being started, Sandeep? I because I still see the option of
Yeah, it is recording. I can see it is recording.
oh, okay. I think there is something wrong then. Sure. All right.
Yeah, yeah,
Please
no
continue.
problem,
Sorry. Yeah.
no problem. Yeah, so we are talking about containerization, and let's try to understand what containerization is. So you'd want to compare two things. One is your virtual VMs and your containers, right? So if you look at VMs architecture, basically it has a physical server, okay, and then you have a hypervisor installed on top of that, and then you will see your VMs are spun up on top of that, right? And your each of those instances will have packaged the again a guest OS. Additional guest OS is required with the binaries application, of course, and then you again have this VM guest OS on top of it. So basically, what happens is it becomes very bulky with the virtual machines. So if you want to correlate with what you might be using day to day, you might have customers who might be giving you some access to connect to virtual machines from where you can log in, and you can utilize their machine there on your on virtual machines. You can it's just like you're remote logging into some other system where there is, say, Ubuntu installed or some other operating system installed, and you can start using it, right? So that's what is a virtual machine. But now if I want to understand how container is different from that, is that here you definitely have a physical server, which is again a VM, all right, and then you have a operating system which it requires, and on top of that you have a Docker engine, right? Now, the benefit that you get in container is that you'll see that the container just has the application and the binaries bundled together. Okay, so you do not have a guest operating system on top of it. So what happens is it makes it very lightweight and easy to port. So that is one of the benefit of your container. Now, if I want to take a real life example of what a container would be, is like you could probably compare it with a shopping cart. For example, if you just order, say, from a big basket, you just go order some grocery, right? So you'll have a lot of stuff. You'll have a lot of veggies and whatnot, right? A lot of grocery stuff in that list which you'll have ordered. So the person who comes to your house and delivers it to your doorstep, he would probably carry a crate, because there'll be, say, 10 customers, 10 different customers. So you'll have 10 different crates in which he puts all the commodities, and he also puts the bill along with it, right? And he just picks up that crate and puts it in front of your door, and then he hands it over to you. So your container could be probably just that. It's just you have all your stuff, all your grocery in it, and it just comes to your door, and what you have ordered need not be, your neighbor will have ordered something else. So the same benefit your container gives you, as in one container could be running your Java application, the other container could be running maybe a Mule application, the third one would be running some Node.js application or a Python application. So containerization gives you that flexibility. So the same thing, if I correlate with our topic of RTF, you can run multiple different versions of Mule runtime using this approach, which was not possible, right? Even on which is a limitation that we have on-premise or a hybrid implementation. And so to mitigate that issue, and also it gives you a flexibility, right? You can run multiple different runtimes at the same time, and also you can also you can start with 0.02 vcores for a runtime fabric application that you deploy runtime fabric uh, um, all right. So that's about container. I hope at least this gives you some kind of understanding of what is a VM and why we need containers and why we are talking about containers. The reason is that it's easier to ship, it's easier to manage, it allows you to maintain multiple different runtime versions. And there are plus many more benefits. You can probably, we can, if you have more questions on this, you can reach out to me and we can discuss. So coming to runtime fabric, right? We spoke of two different flavors, right? And we're talking about the VM bare metal, um, and then the self-managed Kubernetes. So to understand first what is exactly a runtime fabric. So runtime fabric, it orchestrates and automates the deployment of mule runtimes into containers in any cloud or on-premise system, right? So that's where we talk about two different flavors, right? So cloud and on-premise, both it supports, and it gives you a containerized way of deployment. Next, so if you look at the benefits of this runtime fabric, you can deploy consistently across these three different cloud flavors for now: Azure, AWS, GKE, or a data center. More cloud flavors are to be supported in the future roadmap of this product, but for now, these three are supported: Azure, AWS, and GKE. Again, new runtime versions of same can be deployed. You can It supports multiple different versions, so uh, that we've discussed. And then about scalability, it gives you scale horizontally and redeploy with zero downtime. Yeah, it gives you that benefit which is not available for on-premise. If you're just doing a simple standalone, if you have to have a zero downtime, there's a lot of activities that you need to do, a lot of strategies you need to build around it to achieve that zero downtime. Whereas here in Runtime Fabric, it automatically gives you that zero downtime. Next, it's easier to manage via control plane hosted on MuleSoft. Yes, it gives you the control plane access, so you can actually manage and view your Mule applications that are running in the environment. And no resources are required to support or maintain orchestration and automation, right? So it's automatically taken care by your runtime fabric. You don't have to, in case you're not using runtime fabric, you will have to do a lot of work in maintaining your Kubernetes and your Dockers, right? There's a lot of work that is involved. Here it gives you abstraction, and that's how it makes your life easy. Yeah, so let's understand. So if you look at the roadmap of how Runtime Fabric is evolving, so you would see that earlier it started with the deployment across private clouds, that is AWS, Azure, and on-premise. All right, and then now it supports the K8s, the Kubernetes clusters that are there on Amazon, Google, and Azure. And in future we are going to see support for OpenShift and some other Kubernetes flavors. And in the long run, finally, you'd see it could probably run on any flavor of Kubernetes. So we are here at this stage right now, which you can see. And I think GKE was the latest applied, I mean, supported cloud flavor. Yeah. So now let's try to understand the two different flavors that we're talking of. One is the VM bare metal one, and the other one is a self-managed Kubernetes. So, in case of the VM bare metal, what exactly happens is customers bring in their own hardware, network, and install Runtime Fabric on top of that. So they will bring in the VM, the disk space, networking capability. All of that is supposed to be provided and managed by the customer. All right. So what MuleSoft does is it just provides you the runtime fabric. It provides you the appliance model, and that's how this whole system works. So customer maintains the infrastructure, and MuleSoft maintains the Kubernetes stack, the RTF services, and Mule deployments. So if you look at this, this is your VM bare metal model. So you might have questions, what is a node, how these things work together. So when we do the actual hands-on, you'll kind of correlate, how we are creating a VPC, then how we are creating a VM, so you'll get a better view. So some of the concepts still remain common. So you want to understand what is a node and what is a pod and all of that. So we'll get into those details as we move ahead. So let's try to understand what is a self-managed Kubernetes. So in case of a self-managed Kubernetes, what happens is your Kubernetes is actually provided by your Google providers, your cloud provider, right? So here it could be Azure, it could be Azure, AWS, or Google. So they provide you the Kubernetes services. So we leverage the EKS, AKS, and GKE. So these are nothing but your Kubernetes services provided by the cloud. Now, so this is maintained completely by them, so you do not have to do the additional work of actually maintaining and creating your own Kubernetes and setting up the Terraform and doing all of that. So this is something that's more of a SaaS offering which you can actually use. um, Next, you'll see the applications, right? The nodes are spun up, and then you have all these new applications deployed on top of that. So to understand in short, Runtime Fabric is delivered to customers as a package of components that run on top of existing EKS, AKS, or GKE environment, okay? And customers bring their own Kubernetes ingress controller and external log forwarding and install RTF within that. So basically here, right, the benefit of using self-managed Kubernetes is that the customer need not have to provision for the bare metal infrastructure, the disk space, additional on-prem Kubernetes instances and all of that. So all that is provided by your EKS. All that you need to do is just set up your nodes within the cloud offering. So that's the benefit you get out of this self-managed Kubernetes. It makes life much more simpler. But now again, it depends on customers how they want to, which options they weigh on and which one they would want to take. Whether they want to go for the on-premise instances like the bare metal ones completely, or they would want to go for the cloud self-managed Kubernetes approach. Okay, so if you try to understand, now we come to the actual architecture of this Runtime Fabric appliance. So this is the Runtime Fabric appliance. This is not the self-managed one. We're talking of the appliance model here. So you want to understand here, you have the control plane where you have your runtime manager, API manager, through which you can control all your applications and their deployments. And then you'd have your runtime plane hosted here in a cluster, and you can see there are two different kinds of nodes that are required. One is the controller node and then the worker node. The worker node would have the load balancing capability. It would have an agent with which it could be able to communicate to the control plane, and at the same time do a lot of other activities of managing the worker nodes as well. So the controller node is like the one which controls this whole operation between the control plane and the worker nodes, right? And then you have the worker nodes where your actual mule applications are deployed. So on these worker nodes, you'll see you'll have your pods created. Each of the one single pod will have one mule application. So that is how you have your mule application isolation achieved. Yeah. So this is about your uh, runtime fabric appliance mode, okay, or your VM bare metal, which you talk about, right? Now, if you go to the self-managed Kubernetes, you will see that one thing has got replaced. That is, you do not see the control nodes here. But actually, internally, it is all taken care by the AKS, EKS, and GKA models. Okay, so either if you, in our case, we are talking of GKE, right? We're talking of the Google Kubernetes offering. So that will take care of your complete, spinning up the nodes, creating the nodes, and managing all these worker nodes, right? So you'll see that we can manage them all through these AKS, EKS, and GK. And to additional to this whole concept, right? You also have an external TCP load balancer, right? So this is an external load balancer which will help you to. So if an external system requires to reach your mule application and there needs to be interaction with the outside world, you would need a load balancer which will be able to route that request to your worker node mule application. So that is taken care by a load balancer. And of course, you need to have an ingress controller configured, because your ingress controller will have the details of your mule application. Now, just to get a little bit more in detail of how the mule applications are deployed, every time you make a deployment from your runtime manager, it creates an instance of your mule application, or it deploys the mule application in a pod. Okay, So your pod will have a mule runtime instance, and it will also have your mule application, actual mule application, which is running. And every time a pod gets created, an internal IP address gets allocated to that. Now, so since every time you make a redeployment or when you make a fresh deployment, a new IP gets created. If that's the case, then what would happen is, how would any application that's trying to reach your mule application's endpoint or API know how at which address it needs to reach. So that's where your ingress controller has a way of mapping that details, and you're able to map this ingress controller reference to your external load balancer, and so basically your APIs can be exposed to the internet or the outside world, right? So that's how this whole thing works. So that's just the basic difference between your VM and your self-managed Kubernetes. So now we want to understand the benefits of self-managed Kubernetes. We're talking a lot about the difference between them. Now let's try and understand the benefits here. So basically, lower cost. So EKS, AKS, or GKE replaces the controller nodes, which you've seen, right? So it completely replaces the controller nodes. If I just go back here, you've seen the controller nodes here. So it replaces that, so it gives you, so that's one benefit. And then yes, it also it's, if you look at the cost effectiveness, it's like, hardly it's 10 cents per hour for the GKE. The cluster itself is I don't think is built. It's only the nodes that get spun up, they are charged. Okay. And then it gives you more customizable approach of maintaining your environment, and we can choose your own ingress controller which you want to install, which is not the case with your VM and your bare metal options. Then less overhead. It gives you high availability because that's completely taken care by your cloud provider. They take care of the high availability of your AKS. So that overhead is reduced. Basically, it reduces your infrastructure and operations investment, because that is completely taken care by your cloud provider. And then it manages worker nodes, simplifies node scaling and upgrades. Yeah, so it gives you a better scaling. So that option is great to have. So a little bit of comparison of what is supported by RTF on both these options. So if you look at the deployment model, yes, both of them support deployment, okay, from your runtime manager. And then Kubernetes and Docker. Customers, for in case of self-managed Kubernetes, customers bring their own Kubernetes via EKS, AKS clusters. In case of RTA, in case of VM bare metal, you'll probably need to use your Terraform, build it, completely from scratch on that machine. So that involves a lot of operations, basically the infrastructure and operations. Then support for installation on Linux distribution, it's supported on the self-managed Kubernetes. In case of VM and bare metal, it's only on RHEL and CentOS OS. So RHEL is your Red Hat Enterprise Linux, and CentOS is another flavor of Linux. These are the only two which are supported currently. Then auto scaling, right? So in terms of auto scaling, this is supported by Azure, AWS, and GKE. For the VM bare metal, it's not the auto scaling is not supported, but you'll have to take care of that. You need to strategize and ensure that you have based on your volumetrics and your actual capacity requirements, you'll have to model your VM and bare metal. That has to be taken care. That's the additional overhead, but auto scaling is supported by a self-managed Kubernetes. Support for external log forwarding. Yes, customers can bring their own external log forwarding. You can have different kinds of log forwarding like Splunk, ELKs, etc. In case of VM bare metal, yes, it is included. You can, it's already there available. You can utilize the one that is already offered. Support for internal load balancer. Then customers bring their own internal load balancer, that is ingress controller. So you can use Nginx, F5s. You can use those and you can customize. In case of the VM bare metal, yes, it's already available. You can utilize which is already provided. Support for endpoint security edge is currently not supported on self-managed Kubernetes, but it is supported on your VM bare metal. But you can have the last mile security configurations that you can do for self-managed Kubernetes. So yes, we can check that feature. Then Ops Center, right? So this is not included. Customers can enable similar monitoring alerting using AWS, Google, or Azure Cloud Console. The reason is since we are taking the offerings from the cloud providers, this needs to be this is basically the operations is you'll have to take care from the console of the cloud offering. In case of VMware Metal, yes, this is already included.
So, Sid, sorry to interrupt you. There is a quick question from Vijay actually. So he's asking, is there any latency expected in self-managed Kubernetes as the control plane hosted by MuleSoft and runtime managed by the customer, you know? So he's asking, is there any latency is experiencing?
It's a good question. Basically, when you say latency, in terms of, are you talking about are you talking about uh, the actual transaction latency, or are you talking about the deployments that you do? Basically, it gives you zero downtime deployment,
Yeah,
right?
he's talking about the transaction latency. I think so.
So from the external world, so basically, once you've already deployed your mule application and then you have your request and response, no, it does not give you any. It gives you good speed. There's no issues with latency.
Okay.
If I want to
I
just
think to mitigate that, people are suggesting to be keep it and somewhere on the same regions, right? So that is also a suggestion.
yeah, that standard, yes, those best practices we should definitely follow. Like, you keep it close to the customer, whichever region the customer is using it, the external world customer is using it. For example, you have a shopping cart application, which is, say, somewhere in Europe, so you want to keep your um, region somewhere in Frankfurt or somewhere around that, right? So you have to take care that it's closer to the region. It gives you better speed.
Yeah.
Yeah, but
Yeah.
when it comes to deployment, it is zero time deployment.
Yeah.
You do
Exactly.
not have issues with that.
That's good.
Yeah.
Yeah. Thanks, it. Hope
Just
Vijay.
one question from my side, Sidma. So, in case of, let's say we are going for bare metal one, and we want to do for a node, or we want to go for a node auto scaling. So, we have to do it manually, right? So, inside the virtual machine.
Yes, you'll have to actually set it up, right? You'll actually have to spin it up.
Hmm.
So that auto scaling is not available here. In case of self-managed, you can actually configure. So when we do the hands-on, you'll actually see, when we actually say the number of zones is like, say, we select a zone within availability zone within a region, and then we say the number of nodes that we want to have. So if you can actually go and configure that, right? That option is there where you can actually mention the number of nodes you want. Whereas in RTF, you'll actually have to set that up completely. Yeah.
I mean, yeah, the node backup and primary node, secondary node,
Yeah,
and
lot of infrastructure and operations is involved when it comes to VM bare metals. It's all up to customers which they want to pick. It's not to say that that one is better over the other. These are two different. It all depends on the customer requirements. There are customers who do not want to go for a. See, there will be some customers who are already using Azure AWS GKE, right? They're already using it. Maybe for some of their other applications, they're already on it. So they would want to continue with the same approach. So they would go for this approach. So there might be customers who are using. I'm just trying to extend the question that you asked, just trying to get to more in-depth information about that. So when it comes to your VM bare metal, right, there will be customers who are very, very strict about compliance and other stuff, right? Like maybe some telecom customer, or if there's some government agency, they are very specific about, they do not want to completely host it on using any other cloud offering. So they might say that they want to go for bare metal. So it's all based on the customer needs that we select which one suits them best. But yes, you're right. It involves a lot of operations. The VM and bare metal involve a lot of operations and infrastructure setup. Does that answer your question?
Yeah. Thanks, it.
yep.
Okay. So even before I start with the setup, I just wanted to just show you this architecture of Google Cloud Platform, and then correlate that with what we are going to set up. So basically, you will have a region, okay, and within this within that region you will create this entire region, right? You will create your GKE cluster, right? So once you create this cluster, Kubernetes cluster, within that region you'll have zones, availability zones. So depending on whichever zone you've selected, each of that zone you can spin up nodes, okay? So if you say one node, it'll spin up one node per zone, so you'll have three nodes. If you say three, then you'll have nine nodes, because three per zone. So that way your nodes get spun up, and within each of these nodes you will be able to set up your RTF services, and you'll be able to have your Kubernetes cluster there, and then your RTF services, and you should be able to deploy your mule application into these nodes. So this is what it looks like. um, the intent of this particular meetup that we have today is to keep it very simple. We are not going to go into advanced topics. Maybe we'll have a follow-up call based on the questions and feedback that we get, as to there are any other topics that you'd want to probably explore. Then we will address those. So basically, to summarize the aspect of what we've understood so far, is that the benefits is that from RTF is that it's quicker and easier to spin the nodes, and do the deployments, and centrally you can manage all the applications from your control plane. You will achieve application isolation, okay, because it is containerized. um, and you can run your mule applications on Kubernetes. And your deployment becomes very easy because it's a very simple few clicks, that's all. Okay. Now, in the future, in future, we would want to touch upon some much more detailed topics for RTF. Maybe we would want to explore RTF network architecture, like how we would do an ingress, and how we need to configure and route the requests, what are the best practices or patterns. Then about Kubernetes cluster itself, how we do clustering of these mule applications once they are deployed on the cluster. So you can again put them in a, so how do you put them into a cluster, about that. And then pod sizing, how many pods you need to have for to meet the required capacity, so that we want to touch upon those kind of topics. And last mile security, caching, logging. So there's a vast topic. If you want to just do the theory part, I think 1 hour would not be sufficient. So we're trying to just give you a basic overview of what is RTF, and then just do at least one single setup, so that you are at ease, and you're able to understand and correlate with this theoretical concept. Yeah. So yeah, so that's about it. uh there's one more, sorry. Yeah, so that's about it. So if you want to try the hands-on, what all will be require, I can start on that. But if you still have questions, we can address those. Do we have questions?
Yeah, so there is one more question from Vijay. Sid. So he's asking about the policies basically. So when are deploying the application in RTF in the SMK, so we use the API auto discovery to pull up the API policies, right? So when a transaction happens, so he's asking where this API gateway enforcement happens. Is it in the API manager running in the control plane, or at the RTF, the runtime plane? So where exactly the policies are getting applied?
See, ideally, the policies that you apply is you do it on your API manager. You apply your policies, right? But here, the edge policies, right? There's also a concept of endpoint security policies for edge.
Yeah,
Okay.
additional core policies.
Yes, and this is actually supported. If I showed you here, right, it is actually supported on your VM bare metal, and it's not supported on your. What happened? Is it showing anything? Yeah.
Yeah, we can see that. Yes, yes.
Okay. For me, it's not loading. Okay.
It's
So yeah, so basically your endpoint security edge gives you that abstraction where you can actually apply your policies on your runtime fabric itself, right? So your services which are applied on your node, you can actually, on your endpoint platform, you have runtime fabric, and your policies get applied onto that. So this concept is basically your endpoint security edge, which is specifically available for Runtime Fabric. So if I want to summarize what is your endpoint security edge, it's a feature, that works with Anypoint Runtime Fabric to enforce security policies on nodes. Okay. So if you want to get in detail about the security policies, I think we can take that offline. There are a lot of there's a very it's quite a topic that we can discuss.
Yeah, and we have one more question from Joji actually. So she's asking, do we have a common storage for certificate in GKE similar to AWS Certificate Manager? And is it better to store all our certificate in GKE rather than in Mule application?
Well, it's see it. I would not say that there is any recommended approach. It all depends on how the customer would ask for it. Now, when you're talking about the certificates so she's talking about which certificates, the TLS certificates or the TLS certificates that are applied for the interaction between the outside world. Is that what she's talking about?
TLS only. Yeah.
Okay. So basically, we can see that both options are good. I mean, you can store it in both the places, but it all depends on how the customer wants to store the TLS certificates, right? See, there is no one rule to this. For example, the you can also externalize the way you're storing your certificates, right? It all depends on the customer. But yes, you can use GKE to store your certificates, and also you can use or your on-premise. In case of VMware Metal, there's also a way where you go and apply those TLS certificates on your nodes.
Okay, cool. Okay, hope that answered the questions. I don't think we have any more questions. So we can move ahead with the demo, I think.
Yeah. Just to broaden the topic a little bit about certificates, right? There is also this HashiCorp vault where certificates can be stored. So there is a distributed way of how certificates are stored. So it all depends. There are different models. So every customer has different requirements. Some of them have they are much more mature. They want to externalize their complete way in which they want to store their certificates. They go for something like HashiCorp vault or something like that, right? If you All your cloud providers, I think at least AWS, I'm not sure about GKE, but AWS also provides a managed service for HashiCorp vault. So there are different ways of how you can store it. You have secret managers, I suppose, in AWS. In case of GKE, GKE also has a way of storing that. GKE has a vault where you can store. So you have you have different approaches, whether you want to store it on your cloud providers provided managed service, or you would want to have a separate on-premise instance of that particular service where you can store those certificates, and have a distributed way of how this can be it's provided not just to Mule applications, right? But also to other applications which are hosted in your environment, right? Because TLS certificates are not just going to be used by Mule itself, right? They'll be used by other applications as well. So there is it all depends on your enterprise architecture solution as to what approach they want to take across the board. But a simple brute force approach, if you go for, then yes, just go with whatever is available. Either do it on your Azure or a GKE provided vault, or yeah. So that's one of the approaches. Yeah.
Cool. Okay. So I think
Uh,
uh,
yeah. Yeah. Okay.
yes.
All right. So we'll start with the demo. So first of all, what do you actually require? You'll see a lot of online documentation of how you can set up a GKE on RTF. Sorry, RTF on GKE. So basically, the three things that you really require. One is you need a enterprise Anypoint platform account access, which has Runtime Fabric service enabled on it. Okay, so in case you're working with any of your SIs or your organization, you can ask your org admin to provide you access to Runtime Fabric instance. So all that he has to do is just go to the access management and provide you access or add you to that role which will have access to runtime fabric service. So then it will be visible to you when you click on your runtime manager. You'll be able to see runtime fabrics option enabled for you. So that is what you need first. Next, you need a cloud platform account. So anybody who wants to try hands-on on this, you can create a trial account on Google platform. All right. Um, it comes with a 90 days trial period with around some credit limit. So with that account, you should be able to do the hands-on of setting up this RTF on GKE. And the third thing that you need is you need a valid enterprise license. So you can talk to your so when you're actually doing it for your customers, you will need the enterprise license. You need to apply that so that only after you apply that license, you will be able to deploy your mule application on RTF. Now you need to understand this license key just gets applied on the mule runtime itself. All right. So the other workaround that you are doing, if you're just doing it for your self learning, what you can actually do is just go to just Google in mule download mule runtime, and you can download the mule runtime, and you should be able to just start the mule runtime, and you should see the license. I'll show you that how we can do that. So my entire screen is shared, right, Sandeep? You can see
Yeah.
the, or it's only the PPT download. Mule runtime.
No, we're seeing the browser now.
Okay, you're able to see, right? Okay. So when you say download mule runtime, right, you just go here and just do this and you can download it. Okay. And once it is downloaded, what you can do is what is- let's download it then. It's asking for phone number. Okay, it can download. I'll just show it to you. I had a downloaded version actually. Yeah, it is there. I can have it here. So here, all that you need to do is just go to your bin folder, and since I'm using Mac, what I'm doing is I'm run this folder. We just do a dot slash say start. Just do a mule start. Once you have done this and it has completed, you can even stop it. Okay, not a problem. After you have done this, you can go to your conf folder. Okay, and you will see a mule license key here. It will get generated after you have started the instance. And here you will see a base 64 uh, license generated. Okay, so you can take this license key and apply it. So you don't have to request anyone to provide you a license key, but this is valid only for 30 days. After 30 days, it will expire. So it will not work for you. So only for 30 days it's available, but it's enough for you to do your, if you want to do your hands-on stuff, you can utilize this license key. But you still need an enterprise access to your enterprise account access to your Anypoint platform, which is enabled with Runtime Fabric. So for that, you'll have to connect with your org admin who can provide you that access. All right. In Windows, I've seen one issue that when you download it, it doesn't work. So what you have to do is, in case if you're downloading this same runtime on your Windows, you'll have to go to your bin folder, and then there is a mule bat. There's a mule bat file. Okay, just run this mule bat file. Okay, once it completes, automatically again go to your conf file. You should be able to see it. So don't try to run it from command line. Some people, if you trying to, for example, you go to bin and you try to go to a command prompt and then try to do a dot slash mule start, sometimes it gives you issues. Okay, it doesn't work for you that way. So the best way is just go to the bin folder, just double click on the bat file, mule bat file, this file, and it'll generate a license key which is available in conf, and you can use this license key. So license key file, all right. It comes with a .lic, okay, for you to recognize. And when you open this, it'll have the 64 base converted license key with which you can apply and activate your RTF and deploy your mule application through RTF. Okay, all right. So that was about it, about how you can get your license key for your trial purposes. Um, so there are simple steps of what we're going to, how are we going to set up, what are the different steps involved. So at a very high level, there are 7 simple steps. First of all, ensure that you have those 3 prerequisites, right? Ensure that you have the access to anypoint platform with RTF Fabric service enabled, access to it. Second, have a cloud platform access, your Google Cloud platform access. Okay, and the third one is that you should have a license key. Okay, the Mule runtime license key. Okay, if you have these 3 things, you should be easily able to set up RTF on GKE. Now, the prerequisites for this, you already have it. Next, you need to create a VPC. Okay, so you create a virtual private cloud in on Google platform. After that, you have to create a Kubernetes cluster. Okay, so you create a Kubernetes cluster and associate that with your VPC that you have set up. Then you can verify and connect with your cluster, and after that you have to install your RTF. Okay, all that you'll do is you'll go to your runtime manager, you'll create an instance of RTF, get the access, what is that, you get the activation token from there, and you apply it on your Kubernetes cluster. Okay, so once you do that, you'll be able to install, you'll actually have to also install your RTF on your Kubernetes cluster, and then apply the activation code. Then the last step would be to install the license. Okay, for that I already told you how you can get the temporary license key, and then you can deploy the mule application. Simple, right? Easy. So there are a few commands that you should know, which will help you to validate and understand how to check, all the steps that you've done, if your pod is created or not, if your node is available or not, if your mule app is deployed, how do you go and look at logs? So for that, these are some basic commands. So the first one is get kubectl get namespaces, right? So basically, all the pods that are available on your Kubernetes cluster, they are associated with a namespace. All right. So if you want to understand, if you want to know and list and understand which are the namespaces available, then you can just run this command and you will know which are the namespaces created. So I will show you when we do the demo, so you can correlate. Next, you want to understand, you want to know, if your pod is created or not. So you can just check, you can give a specific namespace hyphen and RTF, and it will list down all the pods that are associated with that particular namespace. Then if you want to know all the pods that are running in your Kubernetes cluster, irrespective of whatever is the namespace, then you can run this command. You'll know which are the different pods that are running. You want to know the nodes that are running on your which are the nodes that are available for you. You can do a kubectl get node. Okay, and so these are the basic commands, right? And then you have this get all namespaces. In this case, it will tell you the this one, right? Get pods with the namespaces, and it'll also list down the nodes that are associated with that pod. As in that pod is running under which node, it'll also give you that. So these are few of those commands. Then kubectl logs, right? Here what you will do is you will give a, if you want to view the logs of your mule application that is deployed, okay, you will give kubectl logs, then the mule application, and then excuse me, you will need to just give the namespace name. Okay, it'll list all the logs of your mule application. All right. And then there are a few commands that you need to know for RTF-CTL. First of all, when you're installing the RTF-CTL on your Kubernetes cluster, you'll need to run this command, which will automatically fetch the latest RTF-CTL instance through this API call, okay, and it will install it. And then you need to give a permission to it, so that you can permission so that it can execute on that particular cluster environment. So you give the chmod. So basically this gives the permission. Then what you do is, once you've gone to the once you get the activation token, activation key um, um, from your runtime manager, um, RTF instance, you should provide that activation key here to validate it and install this RTF. All right, so that is how it will be able to associate the RTF instance that is running on your Kubernetes cluster with the actual control plane in Anypoint platform, right? Then you need to apply the license. So this is required. If you do not apply this license, you will not be able to deploy your Mule application. Okay, it will when you're trying to deploy from your runtime manager, right? It will give you an error with some exit code. Okay, and when you look at the logs, it will say, the license key is not available, or it's not valid, or okay. So basically, it will not allow you to deploy your Mule application. So the minute you want to deploy your Mule application, ensure that before that you've applied your license key. So the license key that you get from your that's the enterprise license key that you'll receive from your customer success manager. You will need to upload it in your Kubernetes cluster, and then you will have to convert it to base 64 by running this particular command, okay, after uploading. And then after that you can apply the license, and you can check, you can validate that license has been applied. Okay, so these are the basic steps, and these are few of the commands that you should know. Basic commands, basically in kubectl, if your Kubernetes, there are loads of other commands which you should know for triaging any issues that you might come across. But just to start with and to do your hands-on, these commands are sufficient for you. All right. So then let's get started. Let's try to create uh, a VPC first. So let's go with the first step. We have all the prerequisites. So let's start with the VPC creation. So this is your home page. So you can see here, this is a trial account that I have. It's a 90 days validity. I still have 74 more days to go. And it comes with some basic credit in the very beginning itself. So you can leverage this for your, hands-on, which you want to do. Okay. So you can check for VPC, right? If you just type in VPC network, so we'll want to create a VPC first. So this is something that's default. You can minimize this, and you can say create VPC network. Is anybody having an access to cloud? Sorry, the Google Cloud console. I mean, anyone has an account already who wants to do the hands-on along with me? Just let me know. So I'll wait for you guys when you're doing it.
No, you can move on now, I think.
Yeah.
I don't think anybody has answered.
If anybody has a account and they want to do it along with me, they can do it. It's not an issue. I can wait for them when they're doing it. That's all. Okay, so RTF, I give it a name. I give a name to this VPC. So I say RTF, I'll say Kochi Meetup. Okay. This is not mandatory. I'm just giving it. You can give the subnet name, and then you have to select the region. Okay. So I can select. The reason why I'm selecting US East 4 is because The Anypoint platform account access which I have is in the same, it's in the same region. So that's the reason I'm selecting US East 4, because if I look at my Anypoint platform account, and if I go to the access management, and runtime manager, you can see here it is US East Virginia, North Virginia, right? So that corresponds to the same region here in Google Cloud. So that's the reason I'm selecting it. And then you need to give the IP address range. So I'll select 10 dot, it's coming up for me, 16. So this gives me maximum subnet range and IPs which I can leverage for my instance of VPC. Anything else I need to update? I think we are good. Okay, leave rest of all the other configurations as default and then just say create. So this should be quick. It doesn't take much time. So you can see it's getting created. The VPC instance is getting created.
So in meantime, there's a quick question from Vijay. Said.
Yeah,
So he's asking the demo is on RTF over self-managed Kubernetes or directly on Google VPC.
it is on self-managed GKE. Yes. Just need to wait for it to get created.
So usually it takes how many minutes?
Yeah, I think it got created. It is created. Now let's create. I think it takes just hardly 2 minutes, not more than that. Next, let's. What was the question again? I just missed out. I was just
The
complete.
question
What?
was, the demo is on RTF over SMK or directly on Google VPC.
Yeah, we are doing it on Google VPC. Yeah, we're doing it on Google VPC.
Okay.
Yeah. So yeah, now you can create a cluster. So okay, I not even. So what you have to do is just if you type in cluster, right? It'll say Kubernetes cluster option. It'll give you. You click on that. It opens up this option for you, and then you say create. Okay, and then select the first option, that is GKE standard, and configure that. All right, and now what you need to do is just key in all the details that is required here. For example, you'll have to provide the, so this is your cluster name. So you want to give it a logical name. So I'll say RTF hyphen, Okay, then we select the region. Okay, I select US East 4 because that's what we are close to with respect to our endpoint platform. Control plane release. I think these we can keep it as default. Next, I think default pool. Here you'll see the number of nodes that we can actually apply. Or sorry, nodes we can actually create for each of those zones. Now, if I'm saying three, the reason why it is showing nine is for the US East 4 region, right? There are three zones uh, associated with it. Okay, there are three zones. So that's the reason if I'm saying three nodes per zone, it is automatically giving me nine. Now, if I make it one, it will say three. So we can actually create three,
Multiplying by 3.
yeah, by three nodes. Next, we'll have to networking. I think networking, we have to update this because we need to associate this particular Kubernetes cluster with the actual VPC that we have. So we already have created a VPC earlier. So we associated with that. Automatically, it will also show you the subnet. And that's about it. I think rest of the other things, you can just leave them default. Don't make any changes to them. Yeah. And then just click on create. This will take at least 3 to 4 minutes for the cluster to get created. Okay. Meanwhile, what we will do is we'll go to Anypoint platform and create a RTF instance so that we get the activation token. So we go to Runtime Manager. So Runtime Fabric, I say create a Runtime Fabric instance. I give it a name. And then I'll select this option, Google Kubernetes Engine. And say accept. Here you can see I have the activation token available here, so I can just copy it and we can use this too. So basically this activation code will help us connect this control plane RTF instance with the Kubernetes cluster. So it is still creating. It will take at least a couple of more minutes. Is anyone also trying to do this along with us? Then let me know if you're facing any issues in case if you're trying. Meanwhile, what you can also do if you're interested is you can probably try to download the Mule runtime and check if you're able to generate the license key on your systems. And let me know if you're facing issues.
So can you go back to that Anypoint platform?
Yeah.
Maybe we can just little more elaborate on the difference between Helm and RTF-CTL.
Yeah, so basically there are two options with which you can configure this RTF, right? Either you can use Helm, okay? So here Helm will give you a couple of there are two different flavors basically. Either you can use Helm or you can use RTF CTL. So if you want to, so what it does is, it gives you an option to configure your RTF instance on your Kubernetes cluster. So there are basically two different flavors. So what you do is you first create, using Helm, you can create a namespace for installing Runtime Fabric components, right? So these are the commands that you can leverage to set up your RTF instance on the Kubernetes cluster. So basically two approaches. You can use either Helm or you can use RTF CTL.
Okay. So guys, any questions if you're having it, you can just put it. So
Additionally to that, right, regarding Helm and RTS CTL, what I'd also want to mention is like Helm actually gives you additional benefits. It actually gives you the additional feature, like for example, you can compare Helm with Terraform. When you want to manage your nodes, you want to do the deployments, all of that. That entire control is provided by Helm
so basically, it
package.
gives you some kind of automation, I believe.
Yeah, it does.
Hmm.
So, in case you want to, for example, you want to create your GKE instance on your actual bare metal instance, right? You want to host that entire cloud using your Terraform and all of that, right? Or maybe you want to use any other flavor. So if any other flavor of cloud. So in those cases also you can, in that case, it gives you those controls. You can leverage these commands, and you can set it up. So both the options are available.
Can we check the other one is created?
Yeah, it is created.
Yeah.
So what we have to do now is just connect to this cluster, and you clicked on the cluster and just connect to this and go with the first option, which is the G Cloud container on Cloud Shell. You can open it in a separate editor. So with this approach, you don't have to actually install separate, CLIs and then do the installation. This is much more simpler way of, trying your hands on. Just click on Open Terminal. So it asks you for authorization. Just authorize it. Okay. And then you need to run a couple of commands to install your RTF CTL on this. So you want to check the namespaces which are available right now. Okay, so here in this namespaces, you don't see anything relevant to your RTF. So first let's install RTF. So here is the command. We'll share these commands with you so you can try it. So this will install the latest version of the RTF CTL on your Kubernetes cluster.
Maybe we can put them in chat.
They want it in the chat?
Yeah, if somebody want to try it.
Oh, great. Yeah. Are you able to get them here in the chat?
Yeah,
Let me know.
is there?
It's there. Okay. Okay, so you've and then you give the permission to the CTL. Basically, this gives you a handler, with which you can interact with your runtime fabric on control plane. Now you give it a permission, right? You've already installed the RTF CTL, but you need to give it execution permissions so that it can work here on this cluster. Okay, so once this has been provided, what you need to do is, now we have already created the activation token, right? Activation token. So what we need to do is just install that here. So we have these commands here. So what you need to do is validate it, right? So first let's run the validate command and then the install command. What was that? Okay, copied. So I put this activation token here. It's applying. Just wait for it. Let it finish. You can ignore these. It's not an issue.
So I think this also takes a little bit time, I guess, right?
Not really. It should happen quickly. I think there's some problem. No, no, it is completed actually.
Okay.
It is actually completed. Okay, and then you just have to run the confirm command after that, I think. Install command, sorry. Let me clear the screen so that you can see it.
So first you have to verify and then activate it.
Yeah. We're almost done. It should not take much time now. You just need to apply the license. It takes just hardly a minute. Before it runs, let me copy the next command. I want to do this one. Yeah, it's ready. So your RTF CTL is installed. Now, even before I do this, right, let me do the previous command, right, where we were. We're getting the namespaces. So now you can see there is a RTF namespace available, which was not there earlier, right? So now let's try to check how many pods are running here. So these are all the pods that are running in this name with all their namespaces listed here. Okay. So right now we don't have any mule application running. The minute we deploy a mule application, you should see that pod of that application listed here. Okay. So that's about it. Now, before I make the deployment, most important work that I need to do is step that I need to do is I need to apply the license. So for that, so before I do that, let's go to the Anypoint platform. Go to the Runtime Fabric. We have it active. What we need to do here is we need to first associate this Runtime Fabric with an environment. That is important. So I associate this one with a demo environment. Say apply location. Okay, we are done. Now we can install the license. Now in my case, since I'm applying a simple license, temporary license, I'm not going to convert it into base 64 because it's already converted format. I just need to apply it. Let's see.
So what you are able to download from that runtime itself is a converted format, right? That's what you're
Is
saying.
it will not directly be there in the converted form. It will be, what happens is first you need to download it and then you need to start your mule instance. You just say mule start, or in case you're using Windows, you just have to click on the mulebat file. Okay, and once you do that, you'll have the license key available here in your conf folder, and it is already in the converted format.
Yeah.
Yeah, that's right. So you just take this. Okay. So I use this command. Okay, it's updated, and what you can do is Control C. Okay, so this is applied. So this is done. What we need to do is just deploy a simple mule application. So what I'm going to do is I already have a ready to use application. It is a simple scheduler flow. It doesn't have any HTTP source. So I will just go and deploy that application. So here you need to note a couple of things. I have mentioned the replica is one. Now, all that this does is, if you mention replica as two, right, it will deploy two instances of the same mule application on the uh, Kubernetes cluster, okay, cluster node, okay. And also, other important point that we should also notice, definitely there is this deployment model. wherein you have rolling update, as in it will give you zero downtime, as in it will when you're deploying something, it will ensure that only after your this application is deployed, it will truncate or it will kill the previous one. So that gives you zero downtime. There is another option which is there, like recreate, as in what it does is it first deletes the existing one and then it deploys. Now it depends you which scenario you would want to go with. Based on your requirement, you can choose your deployment model. um, Next is your reserve CPU, right? So this is your vertical scaling. So basically, it has a upper threshold. It's just what it does is this is your CPU burst that you can set. So minimum vCores that you can allocate to your mule application is 0.02, and based on the resource or your licensing, whatever is the upper limit, you can set it to that, and based on your capacity of your mule application, the amount of resources it might require at the upper end, based on your volumetrics requirement, you can set the upper limit. So what happens only when it actually requires more than zero point 0.2, it will scale up to that, and it will utilize that additional CPU. Okay, but it will not go beyond your CPU limit. This is what is assured that you can utilize. Okay, and this is the memory, 0.7 memory. This is the basic that we can provide. Okay, so I just do a deploy. This will take few seconds. You can do a view status here. Let's keep the next commands ready. So you'd want to definitely check, whether it is running. So you'll need this command. So if you list all the namespaces, you should see a new pod getting created. Let's run this right now and see what is there. Okay. Oh, it's already deployed. Oh, it's saying it's deployed. You can see this. It should take a little bit of time for it to. And once this deployment is completed, we can just go and check the logs. So the command that you will require will be this one, right? So let's customize it. We'll have to give the placeholders here. We'll have to give the mule application name and its namespace where it is created. So sorry. So this is your application. And this is your okay. Say enter. Yeah, you can see this, the log, the simple mule application flow, and we have given the timestamp, so it is showing you that. So it is running. Let's see if it's running here. Yeah, it is running. It's up and running. So this is about it. If you want, you can add one more replica. Okay, I can do this. Add one more instance. And what I will do is I'll say apply changes. What you should see is when you run the namespaces command. Okay. You should see one more instance getting created. So you can see, multiple instances getting created. Okay, so that's about it, Sandeep.
Yep. Any questions from anybody? Any questions related to the demo? Or even if if you don't have any questions now, I think it will be always available. So
Okay, I'm reading the questions here from Vijay, right? He's saying the demo on RTF over self-managed Kubernetes or directly on Google VPC. So don't get confused because we created a VPC. You need to understand. My screen is shared, right?
yeah, yeah, you can go ahead.
Yeah. So I was just going to his question. So if I show you the containerization view here, right? You can see this containerization view, right? So even in your container, first thing that you need is a VM. Okay, so you need a VM, and then you do all this stuff, right? So this is about your containerized. So your question is directly on Google VPC. We need to create a VPC first, okay? That is the first step that we need to do. And only after you create a VPC, then you spin up your self-managed Kubernetes on that particular VPC. Within that VPC, you're running your instance. It is not externally, like for example the VPC that I have created, right? It is for my own account. All right, so within that I'm running it. So that's, but I'm still trying to understand your question. It is a self-managed Kubernetes. It is not a VM and bare metal, that much I can tell you. If you're trying to compare two flavors, then yes, it is on self-managed Kubernetes. But that Kubernetes service, right, is provided by Google. It is not something that we have set up. If you want to set up your own Kubernetes, you'll have to use Terraform or some other offering, and then you have to completely do it from scratch. But here it is actually ready to use, right? It is on one click I can create a Kubernetes cluster. All that I need to do is just go to this Google Cloud and and create a Kubernetes cluster. You might have seen the steps right now, Vijay. Does that answer your question?
Yeah, yeah. Vijay is saying yes, he's got it. Yes.
Okay, no, I was just trying to read his question. Why he was asking this VPC and then this Kubernetes? I was a bit confused. Yeah. Okay,
No worries. No worries. Thanks.
so
Okay,
that's
thanks.
about it. That's about it.
One
Anything
more
else?
question is there. How to create the vanity domain to hit the application? So Joji is asking a question.
I'll probably reach out to you separately on this one because we are not covering that topic here. But
Okay.
yes, you can do this. See, if you're talking of DNS setup and all of that, then your ingress controller and then setting the at the API gateway, you'll have to ensure you have the DNS mapping and all of that. Yes, that is required. So that is the reason we chose a simple mule application which does not have anything to do with HTTP. We tried to keep it as simple as possible and cover it within 1 hour, so that at least we do a crawl, walk, and run. We do the simple aspects of the RTF first, and then we take up the advanced topics maybe in a separate enablement session.
Okay.
Yeah.
Yeah, fine. So I think, yeah, Supriya, Sumit, I think we can wrap it up. Before that, we'll go to the quiz session. So I have three questions, everyone. So I'll be putting those questions one by one in the chat. So you have to give me the answers. So as usually we do, and then whoever is we are announcing the winners when you have to share the email ID with us. So that's a normal thing we do always. So Supriya, Sumit, can we start?
Yeah, sure, sure.
Yeah,
So,
yeah.
as everybody heard Sandeep, he'll be putting a question in the chat window.
Yeah,
So, you can start answering the question, whichever is the right answer, and it will be based on the first come, first basis.
that's correct. That's correct.
And of course, like you will get only one training voucher
Yeah.
for that. So, yeah, I think we'll go with three questions, Sandeep. So, Sandeep is putting a question. Everybody have an eye on the window.
Yeah, so
Yeah.
I'm putting it in the general chat, okay? So please have a look
Yes,
and
yes,
you can just
yes.
respond to me in the chat itself, okay? So here goes the first question. Okay, so you can let me know. So it says in order to monitor or administer RTF in requires the use of a control plane hosted by MuleSoft. True or false? Yeah, so of course we require a control plane hosted by MuleSoft. And Rakesh Reddy has answered first. Probably Rakesh can share the email ID, I believe. So Sumit, can you note it down? As soon as Rakesh
Yeah,
probably
yeah.
this email ID.
Rakesh Reddy, please provide your email ID in the same general chat window so that we can have a track of it and we can provide you the training voucher. And make sure you are not participating in the another questions. Even if you participate, you won't get it
I will
even
take the
for
next person.
the
That's it.
first. Uh, yeah, yeah, next person. So that
Okay.
others also have a chance.
Yeah. So Rakesh, can you quickly share the email ID? Then I can go for the next question. Okay. Please do that. Okay. So we don't want to mix things. So that is why.
I think most of the answers are correct, so people were so attentive. Happy to see
Yeah.
that.
So Rakesh, he has given the email ID.
Yes, yes, yes.
Can you note it down?
Yes, yes, I've noted.
Yeah, yeah.
Okay. So here goes the next question. Okay, guys, please watch the screen. Please watch the the chat section. Here comes the next question. Next comes in, the question is node auto scaling is supported in RTF on VMs, bare metal, true or false? Remember the question, VMs or bare metal it is asking. Okay, not an SMK. So
So
false
please
is the right
mind
answer.
meeting
Fa-
yourself. Yeah, thank you.
False is the right answer actually. I think who answered? Naresh Nakka has answered the first one, I believe. Yes, Naresh Nakka. Because it is supported only on SMK model, this auto scaling. So Naresh, can you provide your email address?
Yes, he did. He did, Sandeep.
Okay, Naresh, thanks. So here we have the last question, guys. So please observe the chat again. Here comes. So the question here is, what is the recommended production configuration of RTF appliance model? Is it one controller, two workers? Is it two controllers, two workers? Is it three controllers, three workers, or none of the above?
Sandeep, I think you should change that question because I've not covered that. I think in the demo.
No, that's fine. That's fine. I think there was one of the question was there. You showed the production model of there was a slide. There was a slide.
As a benefit of doubt, I would say ask them one more question probably.
But I think somebody has answered. Yes, Vijay has asked answered the question actually correctly.
Okay.
Yep, Vijay has answered the question.
So I will answer that question if it's done. If you've selected the winner, then I'll answer that question as well. I'll try to detail
Yeah.
that a little bit.
So the production its recommendation is three controllers and three workers on the RTF appliance
So,
model actually.
Vijay, share your email ID, please.
Yeah, Siddham, you said you can go ahead.
Yeah. So for a non-production, right, and that is for a VM bare metal. What we do is, if it is a non-production, at least you should have one controller and two workers. But for production, it's recommended that you have three workers and three controllers and three workers. Yeah.
Yeah, that's correct. Okay, cool. So I think we got Vijay's email ID as well.
Yes, yes, we got. I request everybody to switch on their videos. We'll need nice picture of all of us together.
Yeah, we'll quickly
So,
take a picture.
can you
So
please,
we
switch
will
on your
make
video?
the host.
Yeah, we'll make you host, and then you can switch on the.
Yeah. So we're just making them. Give us like maybe 2-3 minutes more. We are just almost done.
Siddhama, thank you so much for your wonderful session. It was amazing.
These kind of sessions require a lot of patience actually. That's what I'm just appreciating, Sid. So is anybody left with the host?
Anyone's video is like on, probably they can come. They can just switch on their like participate.
Hello, hello.